Welcome back. This is part 3 of our tile-based game project. And in this video, we're going to talk about making our movement smoother and how that impacts our wall collisions. In our last video, we had our player moving around and we had our map loading and our walls placed where we wanted them to be. But the way we did our movement was the simplest way possible, which is one step at a time. Every time you press the arrow key, the player takes one step to that direction and always is on one square. So this is really perfect for if you want to do a turn-based game, something like a classic roguelike where when I press right and my character takes a step, that's when the enemies will take a step towards me. Everything will change, as I take a turn. And that's fine if that's the direction you're going in, but we want to build something a little bit more action-y. So we're going to improve our movement and give us a little more freedom to move around in real time without having to take one step at a time. Okay, so the first thing I'm going to do is I'm going to go over here and I'm going to make some player settings in our settings file. We're going to set up player speed, and now that can be whatever we want it to be. I'm just going to put a number in here sort of at random just to see what it comes out as, and as we start playing around with it, we'll modify this to be a speed we like. Okay, and now over to our sprites. So actually in our main, we're going to take out all of this key-based movement. This is what's making us take a step every time we press a key. We're going to get rid of that, because what we're going to do is we're going to go over to our sprite, and I want my sprite to move. As long as I have the key held down, it's going to move, and when I let go, it's going to stop. Okay, so let's give our player, we're going to use for our position, we're going to have a velocity. So let's give ourselves a Vx and a Vy. Okay, and those are both going to be 0 to start with. And let's go ahead and define what our keys are going to do. If we make this in our own little method, then it'll make it easier to modify later if we want to change how the keys behave. Okay, so what we're going to do is we're going to check get keys every frame, and it's going to set Vx and Vy to 0 unless one of the keys is pressed. So we're going to do key.getPressed. Okay, that's going to let us see which keys are currently held down. And what we're going to do is we're going to say if it's K left, and here's where we can go ahead and be friendly to those who like the WASD keys. We'll make it work with left or A. So if you press left or A, then your Vx is going to be equal to negative player speed, right? So we're going to the left, that needs to be a negative number. And then we're going to say elif, and I'm just going to go ahead and copy and paste to make this a little quicker. And then we will duplicate that 2 more times. Okay, so if we press right or D, then our Vx is going to be our player speed. And if we press up or W, then our Vy is going to be negative player speed. And if we press down or S, then we get our Vy will be a positive of our player speed. All right, let's get rid of, well, I'm not going to get rid of it, but we're going to change this def move and the collide with walls. Those are going to have to change. for right now, in our update, let's just do get keys. And our rectangles x and y are going to be equal to our games, our self.vx, sorry, plus equals, times the time step of the game. Remember, over here in our game, we are in our update, our main loop, we are getting the delta t of the previous frame so that we will be sure to move at a consistent speed, not based on our frame rate, independent of our frame rate. If you're unclear on how that works, I have a little video explaining that, which I'll link to below, and you can review how the frame independent movement works. And then we're going to make these be, this is the x and the y that we're changing here, not the rectangle, because this number is going to be a fraction because we're multiplying by some decimal, and so we're going to be moving at a value that is not necessarily an integer, and rectangles, they got to be integers, so we'll be losing information if we add that. So we're going to keep these to be our position, and then we can just set our rectangle. And now, which part of our rectangle we use, that's another option we can talk about once we get this all completed and have some graphics and talk about how we want our character to look and interact with the walls and all that kind of stuff. So we'll go over to our main and run this, and now we should see that we can move in the 4 directions. Not particularly fast, because we put 100 here, that's 100 pixels per second, and since our screen is 1,000 across, that means it takes 10 seconds to cross the screen, which, if you noticed how fast our guy was moving, that's probably about right. It's taking about 10 seconds to run across the screen, which is a little bit too slow. So let's increase that speed a little bit. Let's try 500. Yeah. Whoa, that's super fast. Okay. That might be a little too fast. So we'll go over here and we'll split the difference. And we'll try 300. Yeah. Okay. That's comfortable. At least for now. So now we need to make our sprite collide with the walls. And you might have noticed, which I just did, we're not spawning in the right spot, which is because we're telling it what row and column to spawn in from our map, and in our sprite we just need to make that, convert that to the x and y, which is times tile size. Okay. Alright, so we spawn where we're supposed to spawn. Now I want to be able to collide with the walls. Now there's a few different ways we can do this. It's also going to make a difference whether we decide we want to allow diagonal movement or not. Right now we can only move in 4 directions. We might want to allow diagonal. Diagonal is pretty easy to add. In fact, we can just go over here to our get keys and we can change those elifs to ifs, and that's really all you have to do, except for the fact that we need to change a little bit so that our diagonals aren't faster than our horizontal and vertical, right? The diagonal problem, which I've talked about before and even have a little video on, which you can see below as well. So real quick, we will say if oops, left out my 0 there. So if both Vx and Vy are not 0, then we need to take Vx and Vy and multiply them by 7071, which is the square root of 2. Or sorry, 1 over the square root of 2. Which is explained in that video. It comes from the Pythagorean theorem. Okay, so we are now moving diagonally, and we need to talk about colliding with the walls. Now what we could do, which is how we did it last time, was if we're moving, any frame where we try to move, we're going to check to see if we collide with a wall. If we collide with a wall, then we don't let the sprite make that move. Okay, and we could do that. So let's try that. Right here, we move ourselves. So let's just do a collision. And for this, we can use the sprite collide any command. The sprite collide any is a bit faster. It checks between a sprite and a group, which would be game.walls. And it just tells you, it just gives you a true or false if this sprite hit anything in this group. It doesn't tell you which one it hit, but we don't care. If we hit a wall, we can't move. So that means we need to basically undo this movement. So if we put that, we can just put minus, right? So we undo the movement. We move back the same amount of pixels we moved forward. And what that's going to do is a couple of things. One is it's not going to let us go through the walls anymore. But you're going to notice that sometimes, like here, I'm pushing up, I can be against the wall. But other times, like there, I can't get right against the wall always, because so sometimes the wall has this weird little space where I can't move any closer, like that. And the reason for that is, let's say when I'm right here and I press left, my sprite tries to move 10 pixels, but I'm only 4 pixels away from the wall. So it doesn't let me move. So I'm not able to move that 4 pixels. And what gets worse is when I go diagonally, I just stick against the wall. Now most of the time, and again it depends on how you want your movement to work in your game, but most of the time if we hit a wall diagonally like this, I want to keep sliding downwards, right? If I'm going diagonally, I'll go over here and go diagonally to the down and to the right. When I hit that wall at the bottom, I would like to keep moving to the right and not have to press again to make it go to the right, right? I want to slide along the walls. And the only way to do that, and we also need, and to fix that little gap problem, is going to be to make our collisions a little bit more sophisticated. And what I mean by that is the sprite collide will tell us that our sprite hit a wall sprite. And it can even tell us which sprite it hit. So it's going to tell us we hit this one here at the end of the wall, this bottom one on the wall. We hit it. But that's true no matter what direction we hit it from, right? If I'm moving this way, I want to stop against the wall there. But if I'm moving this way, I want to stop against the wall there. And if I was moving up, and so on. So the way to solve that is you have to break down your movement into X and Y directions and check your collisions twice. So we're going to move our sprite in however many pixels it's supposed to move in X, and we're going to see if we hit a wall. If we hit a wall, we're going to stick ourselves to the side of it, depending on which side we hit. And then we're going to move our sprite in the Y direction, however much it needs to move that way. And if we hit a wall, we stick against the wall that way. And what that'll allow us to do is, if I'm moving diagonally, when I move in X, I'll hit the wall and stop. But when I move in Y, I'm free to keep going. So that's going to let me slide along the wall. Okay, so let's try that out. All right, so we're going to throw this away. That's not the way we want to do our wall collision. And what we're going to do is this X and Y are calculating what our new position needs to be. So we're going to move our rectangles we're going to set our rectangle's x equal to that x, so that we can check if we need to collide with the walls. Okay, and then we're going to go collide with walls, and we're going to say we're going to collide with walls in the x direction. Then we're going to set our rectangle's y where it's supposed to be, and we're going to collide with walls again in the y direction. So 2 collision checks, 1 for each axis. So that means we need to change this collide with walls. And you know what? I'm going to go ahead and delete this def move. That is out of date and doesn't work right anymore. So colliding with the walls, and we're just going to put that we need to specify the direction. So if we're checking an x collision, then we need to do the sprite collide between ourselves and the walls group, false, because the walls don't get deleted. If we hit something, I don't really care how many walls I hit, because if I come in right in between 2 walls and hit them at the same time, it's still the same result. I need to stop moving in that direction. So if I hit something, then we have 2 choices. Either I hit it from the right side and I need to press up against its right side, or I hit it from the left side and I need to be against its left side. So we need to check to see what was our velocity, and Vx. So if our Vx was greater than 0, that means our sprite was moving to the right when it collided with the wall. So we need to put ourselves against the right edge of the wall. So our self.x is going to be whatever the thing was that we hit, .rect.left, minus however wide we are. So that will put us right against it on its left-hand side, because we are moving to the right. Now, in the opposite direction, if our speed was less than 0, then we were moving to the left, and we need to hit against the right-hand side of the wall block. So we're going to put ourselves against the rect.right. And regardless of which direction we hit in, we're going to set our Vx to 0, because we shouldn't move anymore. We ran into a wall. And we'll put our rectangle at that new position we decided we should be at. And we can go over to our game and even try it out. Our X collisions should work. Our Y collisions are not going to work, but you can see I can slide along that. Y is not going to work, because we need to do the same process for Y. So I'm just going to actually take this whole thing and I'm going to duplicate it. It's almost the same. We got some indenting, auto indenting happening. I have to change that setting. It's almost the same thing. What's going to change is when we move in the Y, we're going to check the collision, and then we're going to check if our Vy was greater or less than 0. Right? If our Vy was greater than 0, we were moving down. So that means we hit the top of the block. So we need to be at the top minus whatever our height is. And if we were moving up, we need to be at the bottom. And we set our Vy to 0, and we set our rectangle's Y. And now we have both axes working, and I should be able to run around and I can slide along the blocks. No problem, no getting stuck, right? I get to slide along it diagonally, and everything looks good. Okay, that video went a little bit long. Hopefully it made sense and you have your player moving around the way you want them to move in your map that you built. And in the next video, we'll talk a little bit more about wrapping up our movement, and then talk about a little bit more about what kind of game we might make. If you have some guesses, post them in the comments below. Maybe we can see who's closest to guessing the right direction that I'm thinking of taking this project in. As always, thank you so much for watching. Please press that like button below and subscribe if you haven't already so that you'll get the next video when it comes out very soon. See you next time.